Hello. This year we're gonna talk with Clemens Szyperski, right? And last year we talked with your colleague from Microsoft, Wojtek Kozaczyński. He talked about telemetry solution based on Azure. So maybe this time you will tell us a little bit about the Azure itself, how it looks like. What is it?
Okay, yeah, sure. Yeah, I mean, the entire cloud idea is very abstract, right? It's like you normally think of having a machine that is in front of you, whether it's a tablet or something. For cloud systems, everything by design, everything is far removed from you. So the actual data centers are sort of like high security buildings that sit somewhere. They don't normally sit where you might expect them to sit. Instead, they sit close to cheap electrical power, because every one of those data centers is a huge consumer of power. And so now we're looking at data centers close to hydroelectric power and some creative thinking around using solar power and other things. So when you then go and say, okay, now I have maybe 40 of these data center locations around the globe for Azure, separated into 25 or so regions. If you go and open one of those buildings up, you just see rows and rows and rows of machines. So Azure at the physical level is just monstrous amounts of machines in big concrete cages. And then you can say, so what can I do with all that? Right? And so if I have these millions of machines that are kind of stored away in big buildings, everything else is basically an illusion, right? Everything else is a world of services that are like websites and that you can approach from anywhere in the world. They have endpoints. You can send commands. You can get results back. You can deploy resources. You can receive bills for the resources you deployed that you end up paying. So that's the kind of outer shape, if you like, of a system like Azure.
Okay, well, I wanted to ask you about the hardware side, but you already told a little bit about it. Yeah. But maybe can you show us or maybe describe us how big a single location is? Can you compare it to, I don't know, a shop?
Yeah, so you would basically, it varies a lot. So in some of our regions, like the two data centers in Australia or in Brazil, are actually pretty small. They have the size of maybe a larger sports court, some building like that, where you may want to play handball or something. And some of the major regions have kind of like superstore-sized buildings, and often multiple of them. So the actual hardware is usually limited to on the order of a few 10,000 machines in one building. And then in the same region, you can have multiple of those data center buildings sitting together. Okay. So then it looks like a little city of stuff.
All right. Okay, so it is really big, right?
Yes.
I would say it's not a small location, not a small
right
building. Okay, so cloud itself is not a totally new product on the market, right?
Right.
You're not the first. How would you describe the difference between Azure and everything else that already is or was on the market?
Right. Yeah, so I would actually first go back in time and look at the electronic data services company that Ross Perot built in the 70s, really. That started with the idea of taking a corporation's large data center and completely outsourcing it. And Ross Perot's business model was basically that he would run the data center for the customer and not charge anything until the customer reported that they were saving money. right? So that he was so convinced that he can operate data centers on behalf of customers better than they could, that he made that his business model. And you may know that he became super rich this way, started a second company, Perot Systems, was a little less successful, ran for president, gave up, stopped it, but got about 30% of the vote in the primary. So that was really in many ways the beginning of the cloud. Then the idea of building large public clouds really started with Amazon's AWS, when they recognized that what they had to build anyway to operate their huge Amazon website was essentially a cloud infrastructure, and it would be better for them to allow others to use it as well, so that they can actually keep modernizing the hardware, growing the system, without having to finance it entirely out of their own retail business. But Amazon was, although probably made the first big splash, in many ways they were not first either. And so there have been hosting companies before them. IBM is a big cloud player before the word cloud was even coined. Microsoft's first investments in international data centers, before we called it cloud or Azure, started in the 90s as well. So it's certainly a long and complicated history.
Yeah, really, from the 90s, it's about 25 years, right? So a long history. Okay, so right now, what can you do with it on top of Azure?
Maybe I connect back to one question you asked before that I hadn't answered, where would I see the differentiation of the Azure cloud from other public cloud systems? And one of the key things that Microsoft tries to leverage is its footprint in the enterprises that predates Azure, and to enable what we call a hybrid cloud solution, where you can take systems on-premise and extend them with or partially move them to the cloud without having to do an all-or-nothing kind of proposition. So this notion of executing your workloads in a hybrid pattern is a certain strong differentiator. The other thing that probably makes Azure today stand out is a really rich investment in higher level platform services, where you have about 120 or so services now in Azure that do very specific things. So there are some that are more run-of-the-mill, like database services. There are some that are far more esoteric. Like, for example, we have a database service called DocumentDB that is effectively a very high reliability store for JSON documents that are indexed, queryable at high performance, and it's totally specialized for that purpose. So it's a schemaless JSON document DB service. And so if that's what your solution needs, then you can just pick it out of the catalog and say, I want one of those, and there it goes.
Okay. Right, so you're saying about dozens of services, different kinds of services, and quite recently Microsoft announced Windows as a service direction. So should we expect that one day Windows will become one of those services, probably running in, I don't know, a web browser?
Yeah, so when we talk about things like Office as a service and Windows as a service, then it's less about Windows itself disappearing from your machines, and it's more about, and Office is kind of ahead in that space, it's more about saying that whatever runs on your local machine is connected back to the cloud and maintained by the cloud, right? Yeah. So instead of saying, oh shoot, I now have a 6-year-old version of Windows that is soon not to be supported anymore, so I need to do something to move it forward, and maybe my hardware doesn't work anymore. The vision is that the operating system and everything else you may want to run, like Office, on your local machine automatically updates and stays current over time, and that instead of paying for Windows or Office once and then having it until it falls apart, you instead pay a subscription model, and in return for that ongoing payment for subscription, you basically have an always current system. And so Windows 10 is already built that way. I think they're still going through some growth pain, but that's what they mean when they say Windows as a service.
Yeah, but the full introduction, I would say, of Windows into cloud service is I think one day it might happen, would be that, as you said, no matter what you have on your local machine, on the other side, you just log in, you go to a web browser, and on the other end, you have a fully functional, newest version of Windows, because you need it with some other software like Office. Or
well, I mean, you can do that today, right? That effectively means that you have your own virtual machine running somewhere in the Azure cloud, and you can pick operating systems. You can pick Linux. You can pick Windows. You can say, I want automatic upgrade to the latest version. So that's something that is already there today. And then indeed you can just go to that machine in your browser and use it.
Well, of course, but what I meant, but maybe didn't say exactly, is it possible that the current maybe distribution channel of Windows, installation locally on a machine and running locally on a machine, is it possible to replace that with a very, very thin client operating system locally and the rest running somewhere in cloud?
Yeah, no, it's totally possible.
Games,
it's totally possible, right? There are examples where this is already done. Yeah, I could absolutely imagine that. I mean, the reality with stuff installed or kind of firmly running on your local machine is really something that shifts all the time. Our networks only like 15 years ago or so were simply not up to a level where remote execution felt like a good thing for interactive applications. Today, if you're lucky enough to be on a kind of state-of-the-art internet connection and a data center is not too far away, running anything locally or running it remotely is almost no difference anymore. And so it's really, I think there's a strong trend in that direction of saying, no matter what hardware you have, and no matter what you want to run, and no matter where you want to run it, will all become very fluid. Yeah.
Right. So, coming back to the initial question, can we expect something like this from Microsoft one day? Because many people right now, I would say, are really, really afraid of this direction, because, they are connecting this, I would say, sentence, Windows as a service, which is right now, with this direction exactly, which will, replace the old version, the old channel. I have something which is locally installed on my machine that I control with something that is somewhere in the cloud, without or beyond my control.
Right.
Is it the direction that we
I don't know for sure. I think to a degree, I think the concern to me seems similar to for someone old enough like me. I can remember the days where it was a meaningful activity to open the hood of my car and saying, well, can I change parts in my car? Can I repair my car? Right. Today, I open the hood and I find lots of fully closed modules. The diagnostics require special tools, and I can't really do anything at all anymore in my car. At the same time, the cars have never been more reliable than they now are, and so I don't actually care anymore. So it's a different concern, I understand, but it's a similar situation where you grow up with the idea that you fully control what you locally install, or at least you hope you fully control it. Turns out most people don't. Most people have all sorts of stuff on their machine that they really rather wouldn't, that either came with the machine when they bought it, or that just got hijack installed on your machine just because you visit the wrong website or something, right? And so I think the reality is is a little different from what people think it is. But I think most people will move forward and not care as long as the trust is there, right? And I think trust is in this case the single most important thing. And it's easy to lose trust and very hard to build trust. So companies need to be super, super careful with that.
Yeah, I would definitely agree with that. So and at that point, I would say that much of that trust disappeared somewhere. I don't know, year, 2 years ago, when the whole case with telemetry appeared.
Okay,
news,
yes. Yeah, I think you asked Wojtek about that too last year.
Yeah,
right? Yes.
So,
so that's a very interesting point. So Windows these days, starting before Windows 10, but certainly with Windows 10, is quite strongly tethered back to the cloud and sends a lot of data back to the cloud. Right, no question. You can turn it off, but it's not even easy to turn off. Right, so a lot of people also got frustrated that if I want to turn it all off, I spent quite some time even searching the web to find out how to turn it all off. I can tell you, but of course, it's a different question whether you want to believe me. But I can tell you that what actually happens on the other side with the actual data, things are extremely locked down. So most people working for Microsoft, for example, have zero access to that data. Not because we know that we're pulling data from machines that we shouldn't, but because it's always possible that that data can be used indirectly to infer something that is problematic. Right, so for example, the telemetry data is supposed to be free of personally identifiable data, but it may not be. Right, there may be something that just, if a person analyzes it, could allow you to see something that you weren't supposed to see, right? And so therefore we are just conservatively assuming that this data, outside of completely automatic analysis for behavioral patterns, has to be locked down and cannot be accessed by almost anyone. So that's kind of a precaution. But the real question is, why do we do this in the first place, right? And that is actually a fairly simple thing. It turned out that thanks to the flexibility of PCs, that there's almost no two PCs on the planet that are exactly the same. That's hardware is different. People have a myriad of different printers, and there's no end to it, right? And so things go wrong, and they often go wrong in a tiny number of places in a particular way. So really understanding what happened. How can we fix this? How can we automatically push repairs so that the stuff starts working again, requires that information. And that's really the primary purpose, to understand what do people do with their machines, not in the sense of what do you type into Word, but in the sense of you are running Word. You are running Word 2 hours a day. You are not you with your name, but you're some anonymized representation of a user who happens to use Word 2 hours a day, and we don't care about this one user. We're looking at like 600 million or so users. We care about, are there patterns? Are there certain things happening? It's also about, for example, the outbreak of certain malwares where you can actually see how these machines start behaving differently. So that's why this is all done. But it's, yes, I think trust is in this case an endangered species. And I think we should be more forthright about explaining what we're actually doing, and why we're doing it and how we're doing it.
And is there any chance to see what kind of data is transmitted, to verify the content, or maybe just to take a look inside? For IT specialists, it would be, or students, it would be very, very good lesson to take a look. So I don't know. This would have to be instrumented on the sending machine side. Otherwise, we would create a huge can of worms. If we somehow allowed the cloud data itself to be mined by people, you'd have to say, well, how do you know that this is actually your machine and not someone else's machine that you know after? So that is conceivable, that your local machine could simply tell you. You would still have to believe it, but it could tell you what it is sending. The fact that it's sending everything in encrypted form over encrypted channels is really to protect you and not to hide things from you, because otherwise this information could be tapped by anyone. Right, but what if we used an Azure account and with telemetry, telemetry service on Azure cloud and directed, the data there just to see from that side what is being sent. Is it possible?
It's not technically. Well, technically, it could be done. It's not possible today, but that's a good idea. Yeah, why not allow people to say? You would have to pay for it, but why not allow people to say, please send a copy of my telemetry data to an analysis service that I'm paying for, and then I can see exactly what's being sent. Yeah, that's an interesting idea.
Yeah. Well, I'm not talking about every single Mr. Smith in the world, but I'm thinking about universities.
Right. Yeah, no, that's what I'm thinking
students,
too.
Right?
Yes, and so if it's about universities, there's probably a way of making these things available free of charge anyway. Yeah, but I think the general idea of saying come up with a model that allows individuals or researchers, whoever, to truly see what a Windows machine sends, I think that's interesting. Yeah.
Okay. Okay, so thank you for the conversation.
Of course.